Since light is a wave, we're going to use the velocity of a wave equation to explore light further. Recall that v is equal to the wavelength times the frequency. For light, that means the speed of light is always going to be equal to whatever the wavelength or color of the light is, times its frequency. For example, a microwave can have a wavelength equal to 12 centimeters, or 0.12 meters. So what is the frequency of a microwave? Rearranging the above equation, we find that frequency is equal to the speed of light divided by the wavelength. In this case, we plug in the numbers 3 times 10 to the 8 meters per second, all divided by 0.12 meters. Once again, the meters cancel out, and this gives us 2.5 times 10 to the 9 1 seconds, which is 2.5 times 10 to the 9 hertz, or 2.5 gigahertz. Let's try another problem. An X-ray has been measured to have a frequency of 6 times 10 to the 17 hertz. We want to find what the wavelength of this X-ray is. So we have to take C is equal to lambda f, do some rearranging. Lambda is going to be equal to C over frequency. Lambda is going to be 3 times 10 to the 8 meters per second, all divided by 6 times 10 to the 17 hertz. Recall that hertz is a 1 over a second, so this second and the hertz cancel out. So the wavelength of this X-ray happens to be 5 times 10 to the minus 10 meters, which is 0.5 nanometers, or if you prefer, 5 angstroms, which is about twice the width of a single water molecule.